Welcome everyone. In the previous tutorial session, we discussed about supervised machine learning where we discussed about the regression analysis and classification. So in this video, we will deep dive into regression analysis and discuss some of the key regression algorithms. We'll start off this video by discussing linear regression. Then we will discuss about support vector regression. After this, we will discuss the implementation of decision tree regression, and in the last we will discuss about random forest. So without any further delay, let's jump to the very first topic and let's discuss about linear regression. So basically, linear regression is one of the most fundamental kinds of regression technique utilized for predictive analysis. Moreover, we use this regression technique to illustrate the relationship between continuous variables like sales, age, salary, etc. Basically, the term linear regression refers to statistical method that displays linear relationship between the independent variable x and the dependent variable y. Now the key role of linear regression is to show a linear relationship. So it will help to determine the value of the dependent variable based upon the value of independent variable. Moreover, the linear regression model produces a sloping straight line illustrate the correlation between both dependent and independent variables. So here on the screen you can see one sample graph representing the regression line between dependent variable and independent variable. So in the above graph, the straight line which bisects the data points represents the best fit line. The primary objective of the linear regression is to take into account the given data points and plot the best fit line. And this best fit line is plotted to fit the model as accurate as possible. Now to determine the best fit line, we utilize the following equation. Now in this equation, y represents the dependent variable that needs to be projected. After this, there is intercept which is denoted by b0 and it designates the point, a line where it touches the y-axis. On the graph you can see b0 is represented. There is x which represents the independent variable that affects the projection of y. Then there is another component in the equation which is b1 which represents slope, and after this we have the character e in the equation which represents error in the final prediction. The linear regression can also be further classified into two categories. So basically, when there is only one input variable, category of linear regression is known as simple linear regression. However, when there is more than one input variable, that category of linear regression is commonly known as multiple linear regressions. And the previous diagram represents simple linear regression. So I hope with this the concept of linear regression is clear to you. Let's move forward and let's discuss about support vector regression. So support vector regression is another regression technique that allows us to implement both linear as well as non-linear regression. Moreover, this technique is based on the concept of support vector machine. However, in comparison with support vector machine, which is used for predicting discrete values, the support vector regression, commonly known as SVR, is a regressor that is used to predict continuous ordered variables. Now, to understand the concept of support vector regression, we need to first understand what is support vector machine. So basically, in support vector machine, the main goal is to determine the hyperplane in an n-dimensional space where n is the number of features or number of independent variables, and this will distinctly classify the data point. Now here you can see one representation of support vector regression, where very first component you can see a straight line which is hyperplane. Hyperplane is a line used to divide the two data points into groups on a dimension higher than the real dimension. So according to SVR, it is referred to as a line that aids in predicting the desired result. After that, we have boundary lines. So here dotted line represents the boundary line, and these are the two lines positioned 2 units away from the hyperplane, and it is applied to establish a buffer between the data points. And after this you can see support vectors. So support vectors are represented using the extreme data points in the dataset that aids in creating the hyperplane. Support vectors are the data points which are closest to the hyperplane. So I hope with this the idea of support vector regression is clear to you. Now other than this, there is one more important topic related to support vector regression, which is kernel. SVR does regression at higher dimension. In order to accomplish that, we require some function that should map the data point into higher dimension, and the kernel is the name of the operation. So SVR employs various type of kernels including sigmoidal kernel, polynomial kernel, Gaussian kernel, etc. And let's move forward and discuss about decision tree regression. Decision tree is one of the most popular and useful techniques that comes under supervised machine learning. This technique can be utilized to solve both regression as well as classification problems. So generally, a decision tree consists of three different sort of nodes. The initial node is the root node that represent the complete sample, and it further is divided into other nodes. So after the root node, the next node is interior node, or we can also refer it as decision node. This node represents the dataset features, and then there is branching for its decision making process. Finally, the result is represented by the leaf node, which is another type of node, and this technique is useful to solve decision making problems. Basically, in decision tree regression, the entire tree transverses with the specific data points based upon the true false condition until it reaches the leaf node. Moreover, the tree can predict suitable values for data points after many iterations. Now if I discuss about one example related to decision tree, so here on the screen you can see one representation. We are utilizing this decision tree model to predict the price of house based on multiple features of the house. For instance, first the model will check if the house consists of minimum of 4 bedrooms, and based upon that it will take one decision. If the house consists 4 bedrooms, then it will move to the next node which checks the lot size larger than 8,000 square feet, and if the house does not consist 4 bedrooms, then it will move to the other node which checks the lot size if it is greater than 6,500 square feet, and after this the mod will check the lot size, and based upon this the model will predict the price of the house. So with this I hope you got an overview related to decision tree regression. Let's move forward and let's discuss about random forest regression. So basically random forest regression is a supervised machine learning algorithm which employs Ansible learning approach for regression. Now, in order to produce predictions that are more accurate than those from a single model, the Ansible learning model integrates prediction from various machine learning algorithms. So to understand what is random forest, we need to first understand what is Ansible learning. So Ansible learning is a technique which takes predictions from multiple machine learning algorithms, or we can say it takes predictions from same algorithm multiple times in order to make more accurate prediction. Now predictions from a single individual mode might not give that much accurate result. Hence, we will utilize Ansible learning technique to get more accurate results. So a model which composed of several machine learning models is simply known as Ansible learning model. So we can develop several models like decision tree, KNN, SVM, etc. on the same data to get combined result. Similarly, we can have several decision trees trained together to get a final combined prediction. Now, the Ansible learning is categorized into two flavors. First is boosting and second is bagging. In boosting, as the tree advances sequentially, each one will attempt to learn from the errors of the previous tree and decreases the residual error. So in this, individual tree are dependent upon one another. After this, there is bagging. Now bagging on the other hand is a method of learning that frequently takes into account homogeneous weak learners, and it basically trains them independently from one another in parallel and then combines them using some form of average procedure. Now random forest is a bagging Ansible learning technique. Moreover, there are certain drawbacks to use decision tree, and here comes the role of random forest. So let's discuss some of the issues with the decision tree. So very first issue with decision trees is that they are computationally expensive. Then decision trees are very sensitive towards the data on which they are being trained, which results in deviation in the prediction whenever the underlying data changes. So random forest helps to overcome these issues of decision tree algorithm. It is a supervised machine learning technique that makes use of Ansible learning, and it can be utilized for both regression as well as classification. So it includes the use of multiple decision trees and combines the result of each decision tree to determine the final output, and this output can be in terms of classification and regression. So in the case of random forest regression, the result will be in terms of regression only. Now if I talk about the steps of random forest regression, the process starts by selecting n records at random from the dataset. After this, it will build each decision tree separately utilizing the selected samples. Then the output for each decision tree will be produced, and in the last, the final result will be calculated based upon the average of the result from each model respectively. So here on the screen you can see the representation of random forest regression. First, what we do, we take some sample inputs, then using that sample input we build different decision trees. So here you can see starts by building this tree 1, tree 2, and it goes tree 10. Then the result, or we can say the prediction from each decision tree is calculated, and in the last the average will be taken from all the predictions and we will get our final result from the average itself. So with this we have come to the end of this tutorial session where we have discussed about different types of regression algorithms. Thank you so much for watching. We will see you in the next one.